Apologies, let me just start recording. Yep. All right. Yeah. So again, for any modeling system, you typically would require sort of different skills, and you would need each of these domains would work with their own set of tools, and you would need, say, antenna engineers just or RF engineers to kind of be able to talk to your signal processing engineers, right? Because everyone needs to have a common understanding of what they're working towards, right? And that is where you kind of try to model your entire system using diverse approaches. Okay, so sometimes you might just model your systems using code, right? So typically, if you're developing signal processing algorithms, you might use code to describe your uh, your algorithms, or when modeling, say, communication systems. So a lot of that might be just how you arrange bits, how you package bits before transmission, right? At other times, block diagrams make more sense. So as engineers, as scientists, we typically tend to work with drawing things, and block diagrams describe things very well. A typical example would be like control systems, right? So if ever there is a closed loop control of any sense, so your output is some of some process is being fed back to the input. Typically, if you try to describe that in code, it would be difficult to do that. However, if you describe that in a block diagram environment, you understand what happens very quickly, right? So block diagrams can be really useful when describing things at times. At other places, circuit diagrams are really useful. To give you an example, say, take an RLC circuit. Okay, so a typical RLC circuit, which many of you might have learned in maybe your school level, or in your first year of engineering and so on, you typically will have, say, you might have studied resonance, right? So if we say try to understand resonance using mathematical expressions, it might not really be immediately clear that what are we trying to do. But if we say try to describe the entire circuit using elements like R, L, and C, and which we drag and drop together and join up and try to simulate the circuit behavior, that is sort of more useful. It's easier to understand, and so on. Right? So at times, circuit diagrams or physical models, which wherein quantities represent physical elements like current or voltage, are more useful, right? So that is where I think circuit diagrams come into play. And at other times, there's state charts. So typically you would want, say, uh, to model things as set of states. So so think of it as maybe uh, you model something like a temperature control system, where you are looking at, say, if temperature in the room that you're sitting in, if it increases, maybe you'll go and switch on the fan, right? So if you're modeling a system which does that automatically, maybe you'll take a you'll essentially be moving from a fan off state to a fan on state, right? Maybe there is an air conditioner there, so you'll be looking at maybe going from the fan on stage to an AC on stage whenever temperature goes even higher, right? Uh, so there are various ways to kind of model things, and typically, if you're looking at a broad um, example like communications, you'll need these different modeling approaches to kind of uh, work together, right? Uh, so I hope that sort of makes sense. In case you have any questions on this till now, so please feel free to kind of put those in on the chat or so. And this is where Simulink and MATLAB sort of come in. We'll talk more about this in just a bit. You can look at writing MATLAB code or integrating C code. There we'll look at Simulink in a bit. We'll look at modeling libraries, modeling physical systems like circuits using Simscape, and also maybe have a look at state flows or state charts. Uh, so yeah, uh, any questions till now? If not, please feel free to kind of put that in. Yeah. So we'll be looking at wireless systems. Again, it's because of like paucity of time, it's not possible to cover everything, but essentially MATLAB has a set of toolboxes which kind of perform different functions, which you can utilize to kind of model different parts of the entire system. Uh, but we'll look at uh, just modeling parts of it. We aren't looking at modeling the entire system, but this is just meant to be an introduction. Uh, so we'll go ahead with this. Okay, so let's open up MATLAB and Simulink first. Okay, so what I would suggest is if you could all go to, let me just paste the link here on the chat, and you could hopefully please try. So I put in a link to MATLAB, something called MATLAB Online. So this is a browser-based version of MATLAB, uh, which we'll be using for this workshop. So if you could just go ahead and quickly open it up, that would be great. Uh, so what I'll do is I'll maybe open it up in a window wherein which. So let me just show you what it looks like, and yeah. So yeah. So when you initially go to this, you'll probably arrive at a screen like this. What you would need to do is go ahead and sign in. Okay, and simply go ahead, put in your email, and yeah, put in your email, and you can go ahead and work with that. So uh, I would say put in your institute provided email or your organizational email if you have one. If you do not have one, you can go ahead with a Gmail or a Yahoo or a general email account as well. Uh, there should also be an option of sort of if you do not have an account, you should be able to. There should be an option of creating one. So if not, you could just go ahead and create one very quickly. It's just maybe one or two questions, and that's about it. So can everyone maybe take the next 2 to 3 minutes to maybe visit this particular link which I've put on chat and create the account if you do not have one. If you have one, please sign in. Okay. So I'll just leave this out, and uh, I'll just wait for people to kind of wrap this up. For some reason, this is not rendering well at my end, but please go ahead and create one so that we can go and do the sort of hands-on part of it right away. In case you face any issues, please feel free to kind of put them on the chat, and yeah. Yeah. So yeah, thanks process Mukesh to kind of for putting that link in. So you could simply go ahead, sign in. So in case you do not have you do you've never created a Mathworks account, then the signing in would not really work. So you could just go ahead and create a new account right from here. Okay. Uh, so let's just wait for maybe 30 more seconds, and then hopefully we'll move on. Uh, so anyone who has already signed in to MATLAB Online, if you could just maybe leave a yes on the chat, that would be great. Maybe just to let us know that you have been able to do this. Okay, I think Dikshit has been able to. Mahesh as well. Okay, great. Others, please go ahead. Maybe we'll just wait for 10-15 more seconds, and then we'll. Okay. All right. Yeah, then all right. I think people are gradually getting the hang of this as well. Okay, let's go ahead. So what we'll do is we will be using MATLAB Online. So I think once you have been able to create your account, if you're still creating, don't worry about it. Will uh, you should be able to kind of create this anytime. So if you're using MATLAB, so what we'll be using is MATLAB Online. So essentially, it's a browser-based version of MATLAB. You don't require to install it. You'll access it purely through your browser, and so you'll always have access to the latest release of MATLAB, and there are no minimum device specifications. Okay. However, internet access is a requirement. So that will be a case. Okay. So let me just quickly go ahead and show how what MATLAB Online looks like, and then we can go ahead uh, and then see how this works. So again, yeah. Uh, so what would happen is, so let me just maybe sign in quickly with. So I use a Gmail account for signing in. So I'm just demonstrating this for some of you who may not have access to MATLAB. So you can see as soon as I sign in, so I go to matlab.mathworks.com. This is what shows up for me. Okay. So at times you will not. So right now, this is my general Gmail. It is not linked to any licenses. So what you can do is, if you sign in and you get a license, there will you are at an institute which already has a license. It will typically kind of give you an option to open MATLAB Online right away. What you can do is you can either use MATLAB Online Basic, which you can use for up to 20 hours every month, or you can simply say take a trial for 30 days. So what I'll do is I'll maybe use this for I'll simply use MATLAB Online Basic for now. Let me just try it out. Um, and we'll see. Okay, so you can use either the second or the third options to kind of very quickly go ahead and start using it. Okay, so hopefully, uh, so to the others um, who have just started, like please feel free to kind of go to either of the options. Okay. Yeah. So what I'll do is I'll just simply refresh this and we'll just go ahead with it. So any questions till now? I hope everyone has been able to access this. In case you aren't able to, please feel free to kind of drop something and on the chat, and we'll be able to we'll be happy to kind of take it forward. Okay, great. So yeah, let's. So yeah, so this is what your MATLAB online would look like. So this is something called a current folder. Okay, so this might be the default view. So this is your where you will store your data files and so on. This is where your workspace variables kind of show up, and this is where your command window, wherein essentially you can enter anything. So a is equal to 2 plus 3i. So you could kind of go ahead and put in different elements and work with that as well. So what we'll do is we'll look at uh, creating a script and try to work through that. Okay. So right now I'm not looking at building a script from scratch, but we'll look at creating a new live script just by clicking here. Okay. So I just want for you to do one more thing before we begin. So what I have done is I have created some scripts which I'll share with you right away. So uh, I have created a script, some scripts for wireless communications modeling, which I'll share with you and which you can go ahead and look at. So let me just put this in. So okay, so I put a link again for access scripts models here. Just have a look at what I do with these before trying to do this yourself. Okay, so if I visit this particular link, okay, which I just shared with you. If I just visit this particular link, you'll see that right now it's a shared folder which I've shared. It's currently owned by me. You'll be able to only view this. Okay. Uh, you won't be able to edit this. So what I want you to do, if you're working with an installed version of MATLAB, you can simply download this and work with it. And if you're not, you can simply say copy folder. So drag and drop on this and click on copy folder. Okay. If you once I let me just go ahead to copy folder. As soon as I copy this, so this copies the folder onto this location which I talked to you about, MATLAB drive. And now you can see this is owned by you and you have edit access. Okay. So please go ahead and try and do that. You can either download this or you can go ahead and click on the drop down and click on copy folder. Okay. I hope this is clear. So click on this drop down, click on copy folder, or you can download this and start working on it if you have installed MATLAB already. Okay. So I'll just again maybe wait for 1 minute to quickly do this, and then we can go ahead. Uh, so I hope you have been able to copy these scripts. If you could just leave a thumbs up or a yes on the chat once you have been able to do this, that would be great. So that I know some of you have been able to. Okay. You can simply just repeat the instructions again. Simply visit this link, click on this drop down, copy folder. All right. Great. Yeah, I don't see anyone who has been able to. Once you do this, I think you should be able to get something like this. Let me just maybe zoom it up a little bit. You will get this, and you should be owned by you. Okay, and it should also show up in your MATLAB online. So right now you should have a wireless communications folder on your MATLAB online. Okay, so I understand this is on the communication side. Many of you might not really be from this domain, but the idea is just to look at communications as an example, and we will probably look at some of the circuit uh, examples maybe in on Thursday. Okay. Uh, so let's go ahead. I think since we're running a bit short on time, so what we'll do is we'll look at a live script essentially which has code, rich text, images, and so on, and which you can use to kind of model things. Okay, uh, so there are various controls on this, and which you can go ahead and use as well. So let's go ahead and open this up. So what you can do is you can look at the wireless communications folder, double click on this here, and you have, say, a bunch of subfolders inside. So there's one on analog, digital, antenna design, wireless, and so on. So let me just open up one of these. Let me just open up uh, one analog modulation uh, script. Now, uh, okay, so let me just open. So this is so if you see there are a bunch of scripts and so on. So there should be one called amplitude modulation underscore work, okay, as well as another called amplitude modulation underscore solution. So these are pairs. So one is a half complete script, okay, which you can go ahead and run. You can work on, and the other is a completed script. The solution is the completed script which we've already worked on. Okay, uh, so let's look at these. Um, so in the work script, so this is just an introduction to communication systems. So uh, essentially, what you can do is you can define, say, a time step. Uh, so typically when you would start programming and you'd say you want to model, say, behavior of a circuit over time, for example, you'll define a time step for that particular circuit, right? So you'll go ahead and use that. Then you would define a range of time, right? So in this case, I define a range of time from 1 to 5 with a time step of 10 microseconds. Okay. Uh, in this case, I'm defining a carrier frequency. So uh, I'm just doing this because this is like uh, a high frequency carrier signal, which will take which will be used for transmitting a lower frequency signal. And I generate a sine wave out of this. Okay. So if I typically do run this, you can go ahead, modify these values, and you can try running this. If I run this, it will give me the outputs right here, right after wherever in code I defined them. Okay. Uh, and in that sense, and the same elements will appear here. Okay. In that sense, it's very different from regular scripts which you may have written in MATLAB. So these end with a file extension of MLX. So essentially, you can go ahead and generate this. You can then go ahead and plot these signals as well. So for this, what I'll do is you can go ahead, keep your cursor on, say, line 16. And if you look at the live editor window, which opens up, so there is an option called task here, okay, which you can have various tasks which you can go ahead and use. So you can say create plots, optimize things, do some PID control, filter design, and so on and so forth. Okay. So in this case, I'll just go ahead and create a very quick plot. Um, so when I create the plot, what I want to do is I want to kind of try and uh, I want to kind of generate a plot of time versus the carrier signal itself. Okay. So you can go ahead and that very quickly. So I'll just wait for this to kind of do this. So so this will interactively allow you to plot things. The utility of this is essentially if you don't know what sort of plots to make, you can sort of go or you can use that to kind of model things very quickly. Yeah. So another option is to maybe just select the variables which you want to plot. So for example, here I want to plot time versus the carrier signal. So I'll just select these two variables. I'll go to the plots tab, and based on the variables which are selected, I'll just go ahead and uh, yeah, right now it's yeah, right now T and carrier signal are selected. So as soon as I select these two on the plots tab, you'll see that some plots have been activated. Okay. And I can simply go ahead and say create a line plot. And this will open up a line plot in a figure window here for me. So right now it's all very high frequency signals. So let me just go ahead and zoom this a little bit. Again, zoom this a little bit more. So you can see this is what the signal looks like. The same thing here. I'm still, I think that because I'm streaming video, and then this is also using up some of my bandwidth. That's why this is behaving a bit slow. But you can go ahead and try it out as well. So what I'll do is I'll very quickly kind of take you through the solution itself, and then maybe we'll do a very quick Q&A, and then go ahead. Okay. Uh, so let me just go ahead and unlock this. Yeah. So hopefully this is clear. Um, so yeah, so we just went ahead, created a quick plot of the carrier signal, uh, defined a carrier, and so on. We defined a few message frequencies. So in our case, we defined the carrier frequency as, say, uh, whatever we wanted to kind of look at it, maybe 1 kilohertz or so on. In this case, I've defined it as 30 kilohertz, and I've also put in, say, some sort of controls here. So something like, say, a control, like which is like a numeric slider or so on, which you can use to vary values. So this will typically be useful when you kind of look at more changing values in between. So instead of you going and changing one particular value, you can simply go ahead and define what value it is, and then it can also run the rest of the code when you kind of go ahead and uh, uh, try to run this. Okay. So let me run this out. Uh, we'll go ahead and define a message signal very quickly. These are again frequencies which I defined, uh, lower signal frequencies, and we just generate a message signal. So this message signal will look something like this in comparison to a higher frequency carrier signal. Okay. And then simply go ahead and combine the message and the modulation signals. So typically this would be you just multiplying the message signal with something like a modulation index, and then adding it on to the carrier. So which will give you a signal similar to this. So your high frequency carrier modulated with a low frequency message. Uh, Again, let me just maybe quickly see here. Okay. Yeah. So, um, yeah. So again, like a high frequency carrier signal, a high frequency carrier signal which was generated, and then on top of it, a message signal which was generated, and then simply an amplitude modulated signal which was created. Okay. Now, depending upon this, you can go ahead and sort of create like, so this is just one simple example of how a simple mathematical expression was sort of modeled. Now the same thing, if you can go and model more complex examples where, say, you're solving maybe a differential equation, and you're trying to kind of model that, uh, or so on and so forth. Now, very quickly, I just want to kind of look at uh, one more thing. So that is inside the app, inside the folder, you will also have, say, two things, such as the amplitude modulation app. And so, yeah. So yeah, inside your folder, you will also have, say, something like the amplitude modulation app, work, and solution. Okay. So I'll just open up the uh, solution app. So what this does is it will open up the apps page wherein you can go ahead and put in a GUI interface for modeling this entire behavior. Okay. So So whatever you did in a script, you can say package it as an application, and then share it with others without providing them access to the code itself. Okay. Uh, so this is what typically an application design looks like. You can have different, say, sort of GUI elements which you can drag and drop here, and each of the GUI elements will have, say, some code attached to it in the background. Okay. So just by simply dragging and dropping elements in here, you will have generated some code automatically using MATLAB. Okay, and that code is the one appearing in gray over here. Okay, and what I've done is based on, so all of this gray code has been generated just by you dragging and dropping this in this window itself. Okay. And what happens is what I want to do is I simply want to kind of generate an amplitude modulated signal whenever I click this button. Okay. So this button is associated with uh, something called a callback, which you can simply go ahead and define. So in the background, what I'm doing is whenever that button is pressed, whatever we did in the script, we can simply copy that into the app and then have it run. Okay. So so how would this work? So if I say ran this particular app, uh, so this is what the app itself would look like. So let me just say maximize this. So I have, say, a carrier frequency and some modulation index. So let me just go ahead and define a 40 kilohertz carrier frequency. This is my message signal, and say this is my modulation index. I'll just go ahead and update this, or say reduce this. Say update this. So you can see based on what I select, I can change the behavior of the app itself. And this is done with very simple code. So what the idea is, you can do this for essentially any domain. So if you're modeling, say, a circuit, you can go ahead and have in different GUI elements for modeling your circuit, and then you can give results in a systematic fashion, which for others to kind of work with. So unfortunately, this is all we have time for today. Okay. Uh, Please go ahead and explore MATLAB more. Uh, so, and in the meantime, what you can do is, let me just go ahead and uh, what you can do is you can learn MATLAB on your own. I know this was a very quick introduction to many things. So if you see your MATLAB online environment itself, uh, on the right hand side, there is an option called Learn MATLAB. So what you can do is you can simply click on Learn MATLAB, and that will take you to this particular website called MATLAB Academy. Okay. I'll just put a link to this on the chat as well. And here, what you can do is you can uh, you can do free courses on MATLAB right here. Okay. So let me just quickly share this. Uh, yeah, my screen went off for a little bit. Let me just share this here instead. Yeah. I hope this is visible now. Yeah. So this will just open up something called MATLAB Academy, where you can go ahead and uh, do these courses on MATLAB as well as on other on for various aspects. So for example, if you are just beginning to learn MATLAB, I think the MATLAB on-ramp will be a great place to begin. Uh, so this would be a certified course from the Mathworks training services, which you can get uh, a certificate from. So let me just go ahead and see if this works. Let me just see. So I've completed this course earlier. See if this works. For some reason, this is not generating a certificate right away. Yeah. So essentially, this would be, you can see there are a bunch of courses, again, on MATLAB, Simulink, circuit simulation, and so on and so forth, as well as a bunch of other areas which you can go ahead and do. So I would highly recommend, based on your background, selecting a course which you would want to do. But again, say if circuit simulation was an area which you wanted to kind of look at, uh, just modeling RC, RL circuits, and so on, you could go ahead and do this. But just uh, just check that you could simply go ahead and say start the course, but you'll get an uh, you'll get some information on prerequisites for the course and so on. So these are again these courses are very short in duration. So they typically would be just 2 hours long. And these are not video courses. These are essentially courses which you can learn by doing. So yeah, unfortunately, this is getting stuck at my end for some reason. Maybe it's down at our end, but you can go ahead and do these courses. So these are courses where you will have, say, a MATLAB interface on the side, and you have to complete certain tasks to kind of progress to the next level. And uh, these are highly useful, I would say, at any level, and you can typically finish this up into 2 to 3 hours. So maybe tomorrow, what you can do is you can devote some time to kind of doing MATLAB on ramp, and then we can take a step forward and then look at maybe some circuit simulation on Thursday. So yeah. That's all I majorly had for this. There are a bunch of other courses which are there. Please feel free to kind of explore these more. But essentially, there are a lot of free courses available which you can utilize right away. These will give you a course completion certificate and so on, and you can go ahead and utilize this. So yeah, I'm happy to kind of stay back for maybe 5-10 minutes. Happy to discuss more. Uh, I hope this overall overarching introductory talk was useful in some sense. So please feel free to kind of put in any questions you have at this point. You can also email me later any questions, and we'll be happy to talk more. So I'm happy to kind of take on questions on audio as well. So please feel free to kind of unmute and ask away as well. Yeah. I hope whatever we presented today was useful. Please feel free to kind of put in any other feedback if you have as well.
So I think it was quite a useful talk, and I'm sure that many attendee would have used it. At least those who will be not much introduced to the MATLAB. And in fact, even those who are somewhat introduced to the MATLAB, they would have find it very useful. And as we also have one buffer day, so I am sure that you guys
Sure.
can go to the tutorial suggested in this talk and practice a bit, and then maybe the upcoming session will be much more useful for you. And also just Praful, one point I would like to request to you, like if possible, can you also talk a bit more in the next session about, let's say, if you want to interface MATLAB with some existing simulator. Let's say, for example, the simulator is already there, and now you want to interface this MATLAB in order to just grab the data or supply the data.
Sure.
So those interaction like sometimes can be more handy. So I think some of the participant may find that kind of information also useful.
Sure. So maybe we can look at very quick spice simulation and there then maybe interfacing with that,
Yeah,
or maybe
sure.
how you can import a spice model and then
Hi,
start.
Praful.
Yes.
Hi,
Yes.
Praful. One question from my side. This is Sadik here from
Yes.
NXP. Actually, I have been working as analog design engineer. So, how can I use Mathworks as like in for design purpose for, let's say, for any kind of oscillators or crystal oscillators, and how can I use it? And if so, if I can use it, and if I am right now I'm working in Cadence Virtuoso, like what benefits I can get from the Mathworks
Sure.
apart from the Cadence?
Sure. So I would say that, it's not like you have I would say that it's not uh, it's not a one software versus another. Typically, at times, as Professor Ankesh mentioned, it's typically that you can go ahead and utilize these software tools together to do system level modeling. So for example, what would be useful is if you simply go to the Mathworks website and look at the solutions page. So let's look at maybe mixed signal design. Uh, so in here, so you can look at something like how you can link your system level models that you build to other EDA tools to co-simulate and do sort of your verification and validation whether the system level behavior that you are trying to build is useful, is as expected. Okay. So that is how you would maybe look at your sort of mixed signal or analog mixed signal sort of workflow. So this particular page, like if you simply go to Mathworks and look at the solutions page, I think this particular page is what I would recommend. There would be other areas where you typically would do sort of co-simulation with Simulink combined with AMS or Cadence, Virtuoso, and so on. So typically, um, yeah. So uh, you would look at this. Otherwise, and if you simply search for say Cadence and you look at say co-simulating spice models with Cadence or uh, you can see that Cadence and MATLAB are sort of partners as well, because this is it's not say one tool versus another. Typically, in it would be like how can you use these together? So uh, you can look at say integration between the tools. So and if you simply look at just go use the site search on Mathworks website, you'll learn more, and there'll typically be more videos here as well on how you can say co-simulate your models with Cadence and so on. I would also recommend say something like if you simply open up, if you
Okay,
install
so this procedure you can I can get in this.
on the website itself.
And
Yeah,
and
if
for And further, Praful, let me just add few more points because the question is related to more, I think, towards how this can be utilized for the benefit of analog design.
Sure.
So I think the point is this, that the abstraction level at which we work when we use Cadence and when we use MATLAB is sometimes it can be slightly different because MATLAB as a analog designer we use mostly at basic abstraction level when we just want to have the initial modeling. So at that point it is because it is more at mathematical level. You just using bunch of equations and you just want to generate some data and then you want to analyze. So that is the point where the simulators like MATLAB can be very helpful. And later on, once your architecture is built up, even at that time when you want to see the influence of parameters, those things are pretty fast here because everything is at mathematical level. Later on, when you want to like validate this model which you have developed, right? So then you have to go for a spice simulation because spice models are the realistic model which actually try to model the transistor which ultimately will get fabricated, right? So at that level you have to move to the Cadence, but in the beginning when you want to do basically develop the architecture or start at that level, that time these kind of mathematical modeling tools can be very helpful. But yes, these can also be used for gathering data, analyzing them. That is always possible.
Thanks, Professor Jain. Yeah.
Ankesh, sorry to interrupt. Your few lines were interrupted due to noise, I think. Like network was disturbing. Like you mentioned, like at the beginning, architecture we can develop at the virtuoso level, correct? Cadence level. Then for the
No, no,
validation
no, no,
purpose,
no, no, no.
as a
I
method.
said no. I said that when you are developing the architecture, you are actually more at mathematical level. So when you are more at mathematical level, you can
Okay.
take help of design tools which are more at mathematical levels, like MATLAB, or there can be other open source software also. So any tool which is more at mathematical level that can be utilized to do the initial modeling. But later on, you have to move to Spice because Spice models are modeling the actual behavior, right? But those models are much complicated. So you don't want to use them at your initial modeling level when you just developing some architecture.
Yeah.
Okay.
So because
Okay.
because
Got
you're
it.
running these mathematical models, they'll be faster in comparison to 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 you kind of doing the entire simulation there. So you narrow down the design space that way, and then go ahead with the smaller set of parameters going into your spice design.
Yes, exactly.
Okay. Okay. Thank you.
Uh, yeah. Uh, any other questions in case?
So I think if there is no further question, then we can thank the speaker. And Praful, it was really a wonderful session, and we hope that the next session will also be the same in the similar way. It will be useful and entertaining. Thanks a lot
Sure.
for providing this opportunity, and I'm pretty sure that at some point of time we will be hold a in-person session also, which will be
Sure.
much
Yeah.
more useful. Okay, thanks,
Yeah.
Praful, then. Bye-bye.
Yeah.
So,
Thanks
Praful,
everyone.
there
Yeah.
will be a session day after tomorrow, right? So people are
Yes, at
aware
the
about
same time.
this. I think you have
Yes,
already
yes,
discussed, right?
Yes.
yes. We
Okay. And
highlighted
what
this.
will be the outline of that session? It will be some kind of hands-on, or how is it? Can you just brief it before we close?
Yeah, I think we'll look at again circuit simulation. Like now we've tried some modeling in code. We'll look at how you can model in at the system level, where you can say bring in say different circuit elements and then model it, or using say block diagrams, how you can go ahead and model that. Yeah. So primarily we'll look at that. And maybe try to bring in, say, other elements inside. So if you're looking at, say, modeling systems other than the domain that you're working in, then how can you kind of very quickly do that and try to validate your entire approach.
Okay, all right. Thank you, Praful.
Thanks. Yeah, thanks everyone. We'll see you on Thursday evening. Yeah, bye. Have a nice day.
All right. Yeah, thanks.
Thank you. Bye bye.
Thank you.
Bye-bye.
Bye bye.